So phase 3 of how to calculate the circumference of a circle is optional. In this phase, we're going to show you how pi was originally calculated and why pi is 3.14. The reason this phase is optional is it really depends whether or not the kid cares about how pi was calculated in the first place as to whether you want to use this stage. For example, with Rowan, it's absolutely enough that he understands that pi is an infinite number and that the first few digits of it, so that it's 3.14 and so on, and what you can use pi for. So we use it to calculate the circumference of a circle and the area of a circle. He does not care why pi is 3.14, and that information would probably just confuse him. So we're not going to bother with this particular phase with him, but there's a lot of kids out there who will be interested as to why pi is 3.14 and won't just accept that as fact, and for those kids this phase can be really useful. In the following video, we are going to restage how Archimedes of Syracuse first approximated pi and therefore proved that it is in fact simply the ratio of the circumference of a circle and its diameter, remembering that the equation that we use for pi is simply the circumference divided by the diameter. To do that, we're going to go back into the round pen, which is our circle, and we're going to first calculate the circumference of a triangle, then a square, then a pentagon, and then a shape with 17 points, which is the closest approximation to the circumference of the circle that we can get. The reason that we're using the final shape as a shape with 17 points is simply because our round pen has 17 posts that we can wrap the measuring tape around.
Well, this was the note pi left us. What does this exactly say?
Well, this is pi, right?
Yeah, okay. That's the pi word.
And this is equals.
Yeah, I think so too. And what does this mean, the blue line?
It's a division symbol as far as I know.
Yeah, okay, so it means the circumference divided by the diameter.
Okay. And wait, let's just remind ourselves, that was the circumference, right? The diameter was
that all the way across?
One. Yes.
Okay.
So the circumference divided by the diameter is pi.
Yeah, that's pi. Yeah. I was wondering if this also works in the big, huge circle we went with the horse.
Ah.
Should we see?
Yeah.
Okay.
I think let's try and work it out.
Okay.
Yeah, hello.
You're going?
Yeah, you can go.
Oh, I can go.
Cool.
Come with me.
Where are you, Josh?
0.
Where are you, Ilyana?
I'm at 40.
Okay, so that means that the diameter is 40 foot, right? Mm-hmm. And to find pi, we now have to measure the circumference again. Let's try with the measure tape. Well, this doesn't look like a really good circle. I think it's more like a triangle. What does the measure tape say? How much is it all around the triangle? 102. Okay. Shall I help you?
Sure.
Okay. What is it now?
106.
I think it looks like a rectangle now. What if we take more people? Yeah, 1.5 more people. 111. Okay.
We put it all around the posts.
Yeah, that's a good idea. Let's try. Good.
What about now?
128.
Okay, let's have a look if we can find pi here. Shall we look if we can find pi also in the triangle? That was, I think it was 106 divided by 40. That's 2.65. This is a little bit less. This is not pi.
So,
Yeah.
scratch that.
Right.
Right.
And the rectangle?
What was the rectangle again?
I think it was 111.
So we got 111 divided
By 40. That's 2.77 That's still a little
Still not.
less.
At pi.
Yeah. Then we put all the measure tape on the posts. And that
And what
was
was,
128. 128 divided by 43.2.
Okay.
But that's a little bit more than.
But we're not far
Pi.
off with it, that one,
Yeah,
are we?
and maybe it's because our circle is on the inside and the measure tape was on the outside of the posts.
So as you can see from the calculations that Miriam did in the sand, as we moved through the shapes, we got closer and closer to the correct approximation of pi. So the square was better than the triangle and the pentagon was better than the square, and the closest to pi was of course the shape with 17 sides, because that was the closest to the circumference of the circle. We assume we actually got a slightly large approximation of pi because we put the measuring tape around the outside of the posts, making the circumference slightly larger, and we measured the diameter on the inside of the round pen. So what this exercise does is prove to you and the child that if you in fact divide the circumference of a circle by its diameter, you will end up with a number that is as close as possible to pi, so 3.14 or thereabouts. So now that we've done our calculations for pi, Miriam is going to take a hula hoop in the sand, which will act as our circle, and she's going to show you how if you draw those different shapes, you get closer and closer to the circumference of the circle. So she'll show you how the square is better than the triangle, the pentagon is better than the square, and a shape with multiple sides is the closest to the circumference that you can get. This is a really great way of visually representing what you've just done in the round pen for yourself and for the child. In a way, it's how we at Horseboy go about translating that exercise to paper. We just know that if we do it in the sand, which is a fun and sensorily beneficial place for the child to be, it will go so much better than if we try and do it at a desk on paper. Okay, so the translation from exercise to paper is different for every child. When Rowan was younger, it used to take between probably 1 and 6 months, depending on the exercise and how abstract it was and how interested in it he was, to translate to paper. Now we're probably at the stage that it takes somewhere between 1 and 2 weeks, as long as I can figure out how to make the exercise intrinsically interesting for him. The key here is to give the child as much time as they need. As in everything that we're doing, don't put too much pressure on the child. Just allow them the time they need to become confident in the exercise before you try and translate it to paper. And remember, you don't have to use actual paper. You could do something like Miriam did, where you do it in a hula hoop in the sand.
Maybe we can take the hula hoop and make it more visible.
Oh.
So if we had the triangle.
That's a triangle.
And then we did a rectangle. But it's a little closer than a triangle. So I think the more corners we get, the more closer we come to the circumference, and the more closer we will come to pi. Look at this. This is a 1, 2, 3, 4, 5, 6, 7, 8.
But then if you add another few in and get closer and closer.
Yeah.
So if you have 8 sides and then you put another side in between every one, then you suddenly have 16 sides.
Yeah, and you can do that again and again and
double it.
again and again and again.
Yes.
32.
There you go, 32. and then
Yeah.
32 times 2, 64.
64,
times
right.
2. I'm lost.
Yeah, so you can do that again and again and again. And the
And
more
that goes back
corners
to
you have, the
that
more
being-
closer you come to pi.
I think me and you should have a little bit of a challenge.
Yeah,
See how many numbers you can remember of pi
Yeah.
each.
that's a good idea.
And then we can duel off who can remember the most numbers.
Yeah, sounds good.
Remember that again that this phase is optional. You do not have to do this if you think it will confuse the child, and if you think that it's enough for the child that they simply understand what pi is and how to use pi. In the next video we're actually going to show you a different exercise where we do use pi to calculate more accurately the circumference of a circle.